Seeking English S.A.T. Workbook, page 455, problem 2, no calculator, and a calculator will not serve you here. It says, for which of the following equations is y greater than -1 for all values of x? Before I jump in, I want to point out that I'm often saying that an average student in an average amount of time should be able to, with an average problem on the test, be more likely to get it correct than incorrect. This problem might be an exception, not in terms of what I would call normal difficulty, but in terms of the amount of time that it might take a student to get to the correct answer. In class, I don't make students do this problem under the kind of time constraint that the test would demand or imply as an average duration. I want to make sure that they work through the procedure and figure out how the problem actually works, rather than try to guess the correct problem in the correct amount of time. If you learn to do things correctly, then you can learn to do them quickly. Learning to do them quickly and then correctly is kind of a bad order. I know I've stressed this a lot. With this problem, though, students, when they do badly with it, it's not because of the time, like I said. They do badly with this mostly because they're just not sure how to attack the problem. So I'm gonna show you how to attack the problem. It says, for which of the following equations is y greater than -1 for all values of x? Now, you could put in a bunch of values of x, guessing which value of x is going to break the equation. I would not suggest that. What you know should break one of these equations is the number -1. It should be true that if you put in -1, one of these equations will not work. Okay, so the next question is, well, how do we check them? In what order should we check them? Well, first thing is y. If you put in a -1 right here for all of them, you are then just looking for the one that does not work. Okay? How would it not work? Well, since these are quadratics, you could potentially solve for x if you get a 0 over there. That means you just have to add 1 to each side. This becomes 27. This becomes a +1. Sorry, those should both be zeros. 0. This one becomes that. It becomes 0. And this one becomes -1. They're all 0. Now, if you look at it this way, it looks a lot simpler. This one down here, okay, you've got a square minus a square. You've got a solution there. It's x plus 1 times x minus 1, but whatever it is, square minus a square is kind of a dead giveaway. In this case, all you need to do to get a 0 is to zero out this 5, and then it doesn't matter whether you square it and run a negative or not. If you plug in -5 here, okay, you can get a 0. So it's not impossible. Out of these two are similar, except that this one is not. It's not formatted to feed easily through the quadratic formula. So I suggest checking this one first. Okay, and really you probably don't need to check both of them. This one is probably going to give you your answer. It's either going to work or it's not going to work. This one, if you want to, you can make it look like this and then run it, but you'll be using a lot of time. That is not good to use on the test if you could use it more productively on some other problem. So I'm going to run this one quickly. Okay. 2a. Okay, a is 1. That's going to go away. I always like to do c next. And yes, say hello to your algebra teacher. Okay, that's times 27 there. And the 10 becomes -10 here, and this becomes 100, which is 10 squared in here. Okay? Now, if you know offhand that 4 times 25 is 100, then you know this number is going to have an absolute value greater than 100, and it's going to be a negative number, as it happens to be 108. Okay? 100 minus 108 is -8. Okay, square root of -8 is an imaginary number. That's all you need to know. That's all you need to know. So, answer A breaks the thing. Okay, if you demand another video of me where I put this through like I just did to the other one, I can do that. But I want you to develop the habit of saying I'm not going to do that unless I have nothing better to do, unless I'm sitting around at the end of the test having done everything. Only in that case would I go back there and play with it just as a matter of principle.